So this is the last lesson. See how it's 1-3-1? It's the last lesson. Lesson 3 is the last lesson in Unit 1. So my plan is to actually finish this lesson off this week. Next week, a little bit more content, a little bit of studying, 2 days maybe of studying, and then we'll have a unit test next Friday. So it's already a unit test, but it is en route. We're a few days ahead of schedule, which, you know, by the end of the semester, you'll see it's going to be helpful. Okay. Now, this is kind of different. Maybe you've seen this special letter I, which denotes an imaginary number. Or maybe you just hate this idea of an imaginary number. Either way, they're not as tricky as you think. Okay? So what's a number that cannot be under the root? Give me an example and tell me why. 7 is not a perfect root. It's not a perfect square, which could be another, that could be correct. Amy? A negative number. That's what we're going for with this. I didn't feed it enough. So you cannot have a negative number in the root. Because essentially, remember, the square root, if I had the square root of 4, it's saying, well, what number times itself will give me 4? 2 and 2. They both have to be positive numbers or both be negative numbers. So if I had a negative 4 in here, the only way to get the negative 4 is to have one positive 2 and what? One negative 2. Or one positive 4, one negative 1. Okay. So this doesn't work. We cannot have the negative in there because it doesn't make sense with what a square root is asking. So Heron from Alexandria in the 16th century, he's a Greek mathematician, Greek engineer. He came up with this idea. Because with math, what you could say is, when something is impossible, you can make a new rule as long as you follow that rule. You could say, let's let this new letter I, so I'm kind of skipping over to here for a second. We're going to define the letter I as the square root of negative 1. This allows us to continue with the problem instead of having just negative under the root, and we can't do anything else. So when you have a negative under the root, we're using this concept to continue. Complex numbers, the only thing that we have to remember is there's a real component. 3 is obviously the real component. There's an imaginary component. How do we know it's imaginary? Because it has the letter I. Right? I, imaginary numbers. So this is going to be really straightforward. There's like 4 questions in the homework that's just telling you, okay, identify the real and the imaginary. Real, imaginary. Okay. Real. I mean, how hard can I make it? I don't know if I can make it any harder. Is that any harder? Which one's real? Okay, so if you get that concept, then those type of problems, I don't even know if I'll put one like that on the quiz, because the real numbers are just the ones we've been dealing with so far. The imaginary are the values that have an I in the term. Okay. So far, so good. Thumbs up, sideways, down. Have you seen a lot of this? No, that's okay. So maybe it's new to a lot of people. The last Math 2 Plus class I had here, some of them had seen it, but not many. So before you learn today that we can use I, would this be done? Could we do very much more? We'd probably say there's no real solution to it. But because we can use imaginary numbers that aren't real, we can go ahead and break this up. I want you to try this. So let's go ahead and make it negative 1 times 64. All that's under the root. You could then think of it as negative 1 times root 64. And I think from there we're ready to use our definition of I, use what we know about square roots of 64, and let's go ahead and find your answer. I want you to tell your neighbor when you have an idea of what it could be. This is going to be like a leap of faith. So just try to trust yourself for a sec. If you go all in and you end up being wrong, it's okay because you then have something like a counterexample to remember from there on out. Ask your neighbor if you're not sure. Tell your neighbor if you are sure. All right, good talking, good talking. Okay, let's see. How about Thomas? What are we going to end up with? What do you guys say? No clue. What do we know of this? We know root 64 is 8. What did we just learn? The square root of -1 is I. Ada? I heard a lot of ohs. Make a little annotation. Make an arrow to that. Just work it out one at a time. 64, 8. Root -1, I. I put it in this order. 8I. Okay, 8I. Not I, 8. Okay, how about this one right here? I think we could just talk through this one together. What am I going to break this into? What? Root -1? Root 81. All together? Come on, all together. Man, Tomas, you like, your voice spread out. It's crazy. Right. You agree? You agree with that?
Yeah.
Okay, we're good. We're good. All right, this is the one that could give some folks trouble. Now, what I'm always doing when I'm breaking up what's under the radical, I'm always thinking, okay, if it's a negative, I know negative goes there. And then I have 27 left over. Can we break 27 into two values and one of them be a perfect square? For instance, perfect square is 16, perfect square is 4, perfect square is 9. So what can we break 27 into, resulting in a perfect square? What do you think? No? I thought you had an idea. No? Davis. Cube root. So 3 times 3 times 3. That's one way to look at it. One way, that is correct. I was trying to see if we can come up with this version right here. You got that, right? Okay. Because now I know that I'm not going to be able to take that square root of 3 out, but I could take the square root of 9. What is the square root of 9? 3. What is the square root of -1? I. Since we cannot break down that the square root of 3, that is in my answer. 3I root 3. Who needs to see another one like that? Where there's values on the inside and outside of the root? It's no big deal. That's okay. Let's say if I have, -12. -12. Break it into parts. I know -1's going to be in there as part. And then I think of 12. What can I break 12 into that would have a perfect root? Okay. So you see, you got to have a little bit of strategy in there. If you want to break into all the terms, then groups of 2 and pull them out. That's what a square root is saying. Put 2 numbers multiply to give you that inside number. But I'm saying 12 breaks into 3 and 4. So now we have root -1, root 3, root 4. Now we can solve it. Go ahead and solve it and check with your neighbor. Okay, you seen it now in the back? Maybe you got that. You want to help with this just to make sure? Yeah, you're bold. What are you doing? Yes, you can do it. All right, which one of these values can we convert? Maybe take the square root of, maybe substitute. What do you think? Yeah. And then this one's kind of the definition what we're talking about. So square root of 4. 2, I know this is. I. What's left over that we couldn't root? Square root of 3. All these are multiplied together. We just kind of put them next to each other. Yeah? You see it? Just give me a look if you need to see just one more. Just give me one more. Actually, I wasn't very effective. I got weird looks. I couldn't tell. You didn't want to look, then you were looking back. I'm going to keep going because I think we're going to hit this again. I know we're going to hit it again. We're going to go. All right. This is kind of crowded over here, so I'll do my best with it. Okay. This is the I will patent pending. It has been trademarked. Just kidding. It costs a lot to trademark. I've done that before. It takes a lot of time and money. But this is not trademarked for real. But what this shows us is the answers. This is the key. It's the key for the whole lesson, all this week. The answers, when we raise I to different powers. So I to the first is I. We already know it's the square root of -1. I to the second, and then I to the third, then I to the fourth. Watch this, what's going to happen with the wheel. I to the fifth is going to have the same answer as I to the first. I to the sixth is going to have the same answer as I to the second. I to the third is going to have the same answer, I to the seventh is going to have the same answer as I to the third. We're going to show that and figure that out, but first let's find out what each of these is actually going to equal. I to the first is square root of -1. We know that's just equal to I. Answer. I is equal, they're kind of synonymous. It's the definition of I, but we can say if it's I to the first power or equivalent, it's equal to I. What is -1, or square root of -1 times the square root of -1? Essentially, we have the square root of -1 squared. What happens to those two symbols here? Cancels, right? So I to the second power is equal to -1. Because we took the square root of -1 and we multiplied it by another square root of -1. Essentially, we took the square root of -1 and squared it. Square root and square are canceling each other. I to the third power, root -1 times root -1. What did we just say that was? -1. And then what can we say root -1, what's that equivalent to? I. So altogether, I to the third power is -I.
So we don't use the negative
Variable. Yes. So this is the same. I understand now. Yes, that is the same as that. Because it's the first value of that, we don't have to put 1, right? It's like 1 apple or a apple. It's like when it's the first thing, often that thing is left out, like this, right? It's the first power of x, so we can just say it's x. Same thing with this. So however you visualize that, it's going to be fine. This is just simplified. All right, what happens here? Root -1 and root -1? Root -1 and root -1? Echo. Then -1 times -1. Right. Now, this is worth the starburst. Wow. This is worth a trolley. Sour Bites, crawlers, minis. Incentive now. I'm sure it's sour. Sour. Does it make anybody's mouth water? It's really sour. Can somebody explain to me why I to the fifth power would be equivalent to the same value that I to the first power is? Why would that be the case? Nice. I think what you're saying, and see if everyone agrees with this, is that I to the fifth, essentially, right, is I to the fourth times another I. You guys agree with that?
Yeah.
I to the fourth power we just discovered was 1. So guess what I to the fifth power equals? I. You see it? Okay. So let's keep going. Maybe if this was I to the sixth. I to the sixth, you guys agree that's I to the fifth times I? I to the fifth is I. I times I is -1. I times I. I squared we already figured out is this. Okay. It's probably like okay right now, but it does just go around the wheel and it keeps going. So here's the deal. How could I find, using the wheel, I to the 12th power? What would I have to do? If I just had the wheel, I didn't teach you the next trick. What would I have to do? Luciano?
Just keep counting.
Yeah, well, either first, second, third, fourth, fifth, sixth, seventh, eighth, 9th, 10th, 11th, 12th. I know that I to the 12th power is the same as I to the 4th power. It's equal to 1. Okay? Now, this over here, we got to find, what? I don't, let's just say find the exponent. Okay, we're going to find the exponent. What is I to the 17th equivalent to? Now here's the deal. You could go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, count it. Or, but what happens when it's I to the 91st? Repeat that?
You can divide by 4.
You can divide by 4. Okay? Ethan, you agree with that? Yeah. Okay. So watch what happens. Watch what happens. If I have I to the 17th, I take 17, I divide that by 4. How close can we get? 4 gets us to 16. 1. Remember in 3rd grade you had remainder 1?
Yes. Oh my God.
It is Flashback Monday. You have remainder 1. That is now I to the remainder 1, first power. Like this? All right, let's see how much you like it. Let's see if you like it. I to the 91st. All of a sudden, you can do it to 91st. I to the 91st, we take the exponent. I'm dyslexic today as well. And we divide it by 4. Yeah, 3rd. Remainder 3. All right. Let's see. We can get all the way up to 88 with 22. Remainder 3. I to the 3rd. What is the definition of I to the 3rd? Negative I. Okay. All right. We have up here, I think it might be our last one. Yeah, let's do I to the 7th, and then I'm going to stop the video, and we have a couple more up here I want to do. Spinning the wheel for it. So just do I to the 7th. You can count that on the wheel. You could do division. You could do both. Make sure they both work. You get both ways. You know, you divide by 4, you find the remainder pretty quickly, so that's going to be better than counting all the time. Yeah? All right, 7. Let's divide it by 4. 1, 4. 3. Remainder is 3. So I to the 7th is equal to? Yeah, I to the 3rd, which is equal to I to the 3rd is negative I. You guys see it? Aaron?
So would we like it marked down if we left it at like I to the 3rd instead of saying negative I?
Yes. So I want you to write down these, and maybe, you know, when I did the wheel, I think it's like a little bit trickier, but you got to have these definitions down. Okay. And you could deduce them if you need to, like we deduced it on the wall or the wheel with the root negative 1s. But here we have root negative 1. Here we have negative 1, negative I, and 1. If you have these on the top corner, you know, of your classwork today, you'll get the hang of it. This definitely go in your notes. Let's make a key. Good question. Any other questions coming up? Who wants to see just another one of these? Anybody? All right, we'll do a couple more with the spinning of the wheel. That is the lesson for today. Give me thumbs up, sideways, down for it so far. Okay, that looks great. There's a couple sideways. Remember, you can work in groups, so maybe that's where you want to make sure you're partnered with someone. Oh, you guys did really great on the quiz, by the way. This is really great. I think because I had some extra credit in there, the average was actually above 10. Let me just double check here for you, because you guys do really great on those. And we had, all right, we're going to spin the wheel in a sec. In fact, I'll spin the wheel. to start. Okay. All right, let's just do a couple of these. Yeah, your average was 10.24, so that's pretty good. If you got under 7 or below, you can go retake. Come retake. Lunch, except Thursday. Ethan? Oh, you're going to answer that? Okay, so actually the video's still going. Did anybody think of something clever to get them to subscribe? I have to think of it, huh? Where what? I subscribe. I subscribe. All right, how about I subscribe on 3? 1, 2, 3.
I subscribe.
And at home, if they watch the lesson, they know.